about web performance, and I put CSS Grid and PWA on the title to get people's attention. I will eventually talk about that, but what I want for a takeaway for this talk is more about the techniques instead of the technologies, because technology changes and the technique stays. Sorry. My name is Sheldon Lett, and the second word there is actually LED, light emitting diode. My father was studying electronics, so he decided to put that on my name. And despite this very non-Latin name, I'm from Brazil. I was born in São Paulo, which is a very famous city, probably you have heard about that. But I lived most of my life in Goiânia, in the middle of the country. So as I was living far from the coast, I'm not so familiar with the Brazilian beaches. So if you have visited Brazil, you know more about that than me. There are a lot of other Brazilian things that I'm not so familiar with, which football is one of them. I might be interested in the World Cup sometimes, but I'm not a football fan. And also the Brazilian parties, I haven't been in any of them, so I'm not aware of that. But there is one Brazilian thing that I'm very part of the group, which is the beer lovers. And needless to say, I'm very happy to be living here in Dublin. And last thing, there is a Dublin CSS meetup. I invited myself to take care of this meetup, because the organizer have moved back to Romania, and well, I'm going to try to organize a meetup, so the same. If you guys want to talk about CSS and want to sponsor any kind of thing, like maybe you want to help me out with that, you can reach me out at Sheldon. The good thing about having a weird name is that you have a friendly URL for everything, so you can at Sheldon at any social media, and well, that's it. So web performance. Every time that I hear this term, there's kind of a story that goes into my mind, and probably the story may vary, but it's mostly the same for a lot of people that have talked about that. And it's basically like you have an app that you want to deliver to a guy that is in an isolated area using a very low-end phone in a slow connection. And this guy needs to have an acceptable web experience. And then you start to think about things like caching, compressing your assets in order to have smaller chunks to be navigating through the network. You want to like put everything into one single file to have less requests possible, because HTTP requests costs for the user. You also want to like remove comments and white space of those files to make it smaller. And there is this whole backend stuff to make the time to first byte smaller. And when I say backend, it's not only backend, the software engineering part of things, but also database and server and stuff. The metric that is impacted the most is the time to first byte, which is the time that it takes for the user to receive the first byte of content from the response. But I don't know about you guys, but I remember when I started using the internet on mobile, it was kind of okay. But nowadays, if you don't have 4G, it's kind of very frustrating to navigate on the web. And that one of the reasons that people only worry about the network, well, there are a lot of reasons, of course, but one of the reasons is that people worry a lot about the network part of things. But once the resources arrive on the user's phone, on the user's device, there are a lot of other things to worry about. So here is it's a drawing of how your web application will be understood by the browser. First, it receives, I'll be very quick on that, because I think that most of you guys already know that. But, basically, you receive a chunk of text from when you type your address of your application, and then inside of this text, the browser recognizes it as an HTML content and started to parsing it, and then you have the DOM. And then inside of this HTML, we will have links to external assets such as images, JavaScript, CSS, fonts, whatever. And everything needs to be parsed, executed, and applied. For the CSS, the rules needs to be applied to the DOM. JavaScript needs to be executed, and all the listeners and stuff needs to be evaluated. And the browser needs to handle all of that with one single thread. So this is more or less how the browser behaves when it's loading your application. And well, I think that the message here is, well, a while ago we heard this term called mobile first, and it was applied for designing. Like you have to think on mobile first, but also when you start to think about performance, you need to think of mobile first as well. Like phones, they have very powerful browsers, the same as like basically anything that you can run in a browser on a desktop, you can run it on a phone. But phones, they have less powerful CPUs, so they won't perform the same as your computer. They also have less reliable connection. So let's say that here I have Wi-Fi, but then I go outside, I'm on 4G, but then I go inside of a bus, and then now I have 3G, and then I go inside of a tunnel, and then now I have nothing. So it's not reliable, and you have to program your application to behave okay when the network goes down. And phones, they are not plugged in. So of course, that nowadays we have laptops and they are not plugged in as well. Usually when you're using your laptop, you have like a power plug close to yourself. Whereas when you have a phone, you're going to work or taking a trip, and then battery matters. And lately, they have less memory. So when you start loading stuff in your application, well, there are the flagship phones, they have a lot of memory, but if you think about the mid-range, they have like 1, 2, 3, maybe 4 gigas of RAM. And then you have to compete with all the open apps and operating systems, so everything matters. But performance is not only about the metrics, it's also about how the user perceives the performance. So you have to, most people focus about the content that will be seen by the user first. It's usually called as above the fold. And then when you focus on that and try to load this as fast as possible, you can lazy load the rest of the things. And with this technique, you can lazy load basically a lot of all the other assets, like such as images, fonts, styles, and JavaScript as well. There's a video talking about that. There's basically this four steps. So if I can say that. For the user interaction on a website or a web app, first you have the page load here, and this is where we need to clear up everything that is not necessary. Like it's called usually it's called cleaning the critical path. And this is the part of when the user sees something in the phone or in any device, and the user starts reading or understanding the message that your app is telling to them. And in this part, when the user is reading, you have to take advantage of this idle part and load the other assets that you may need in the future. And then you can, there's some scrolling, clicking. We need to be very careful when attaching stuff in animations, such as scrolling. For example, if you start to add in stuff, listeners to perform computational things on that user interaction, your application starts to become slower and slower, and also the response input also needs to be very fast. Your app needs to be reactive to the user input. There are more details here. You can watch this talk later. It's very interesting. So when I told before about clearing the path, the critical path, there is basically like the biggest one, of course, are images. Images, they are responsible for most of the weight of your page. but also you can leverage the lazy loading of CSS in JavaScript. And what people do is basically they have a programmatical way to extract the CSS for the above the fold content, and then use JavaScript to lazy load the rest. But for the JavaScript, you can do that as well, but maybe it's better to think it in a more strategic way and have, for example, you can split your JavaScript for only having the JavaScript necessary for that specific page or for that specific moment. Let's say that your application needs logging, for example. Maybe you don't need to load the whole bundle in this logging area because it's just logging. So if the user succeeds, then you load the rest, and then if you are running, for example, an e-commerce, in the home page, maybe you don't even need JavaScript. So why you are downloading the whole application? And the same, like if you're in the product detail page, why you're loading the JavaScript necessary for the checkout if the user is not even there? And you can say to me like, but if you load the home page the whole JavaScript bundle, then you are caching it, and then in the other pages, the subsequent pages, this file will be cached. Whereas if you split the application, it's not going to be cached, and then you lose that. But then again, we are thinking about the network, and what I want to focus on now is the hardware, is the user's device. So every time, even the application being cached, every time that the user goes to another page, the whole bundle needs to be parsed, evaluated, and executed. The same goes to CSS, but I think that the most painful here is JavaScript. So maybe it's interesting for your application to have your JavaScript splitted. Another very good way to improve performance on that matter is to basically write less JavaScript. And this may mean that, may seem that I'm trying to run away from the problem, but there are a lot of ways to write less JavaScript, or at least deliver less JavaScript. I just told one, which is splitting your JavaScript in different scopes. But you can also, another thing that you don't need to basically do less stuff. Like I'm not saying to remove functionality from your application, but basically doing the same with less code, or doing the same with less computation. So maybe you're right and your code is bigger, but the computer is doing less work, and then you gain performance with that. Another thing that is very interesting is relying on native JavaScript instead of just adding a new library or framework. And basically that's a message for jQuery. I've seen a lot of people using loading the whole jQuery just to do some DOM manipulation or very simple animations, and maybe you don't need to use jQuery for that. You can, or for example, an Ajax call, you can do it with native JavaScript quite easily. There's another very good tip, which is removing that code. And then again, maybe we are not just for example, there is a part of your application, part of a functionality that have been decided to be removed, and then you leave the code there because maybe in the future you want to add it again. Well, that's why you have source control. You can remove it, and maybe in the future, if you want that back, you go back in the history, and then you can look at this code again. Remember that code in the front end is not like in the back end. That's, if the code is there, it's just there occupying space on the server. When you're talking about JavaScript in the front end, if the code is there, this code is not being used by the application, even though the browser will parse, load, extract, parse, execute, and evaluate everything. So you need to take care of your bundle. Yeah, just basically the same story, like refactoring. Maybe you have a new idea of doing the same stuff, but with less computational resource. And this is where I told you that I would talk about CSS Grid. So before I've seen a lot of people using JavaScript for layout and animations. So again, jQuery for just hiding, sliding, very easy, simple stuff. There are a lot of usage of JavaScript for animations, and then very powerful libraries and frameworks for that. But if you're doing very simple things, maybe it's better to just rely on CSS. And for the layout, I think I don't see much use of JavaScript for laying out stuff. For example, before, if you have a dynamic content and you want to display it in several blocks of contents, and then we want this box of contents to have the same height, and then a lot of people were using JavaScript to get the biggest box of content and equalizing everything. I think that the front-end frameworks have this out of the box. For example, data equalize in the foundation, for example. Well, maybe you don't need that anymore because Flexbox you can implement that with like 2 or 3 lines of CSS. And of course, there are way more usages of that, but this is like the main one that I've seen a lot of people struggling with. And when it comes to grid, it's kind of the same stuff, but where in Flexbox you have like one dimension, either a line or a column. In CSS Grid you have 2 dimensions. You can control. It's a grid. And a lot of people, when I tell them to use grid instead of JavaScript or whatever to lay out things, they tell me that they want to support like older browsers. And then I tell them that if you maybe the newer version of grid you can't use it in older browsers, but if you want to use the previous version, it has a very good support. And for example, if you use like prefix, you can have the support down to IE10, and then you can do a lot of stuff. Of course, you won't have like a lot of things that are on CSS Grid, but the basics will have it, and you can do a lot of great stuff with that. And for this specific one, you can remove one library that takes a lot of computational to perform layout, which is the masonry. I don't know if you heard about that. It was very used in the past, and it's still nowadays with to like lay out images and blocks of content very dynamically. And CSS Grid is not meant to replace masonry. So you can't just use the same logic the same way and remove your masonry and use grid. But if you have your content, if you can lay it out imperatively, and you can tell like which part of your content will have which size and which type of space it will occupy on the page, you can use grid very easily, and then you can remove this library from your code base. Now the PWA, I think that at this point in time everybody knows about progressive web apps, but just to give a bit of context, I think that you guys heard this phrase like hundreds of times, but once more, they unite the best of the web with the best of the apps. So and they are a set of technologies. It's not like a fixed list. So maybe in the future, new technologies will come to this list. You may want to support it progressively without breaking an application for the browsers and users that don't have this type of technology. And I think that the biggest and most powerful one is a service worker. And with this one, you can have your application much more performatic, because you can handle cache and offline and non-reliable network very easily, and it's very, very powerful. And with this one, you can even like when it comes to performance, you have like 2 big lens. You have the network friction, and then you have the hardware limitations. So with this one, service worker, you can kind of like have a workaround for improving both ways of performance. And if you start playing around with this, you can have the other stuff, for example, like push notifications to engage the users, the functionality of add to home screen, and I put HTTPS here because your application needs to run under HTTPS in order to have all of that. And the main one, again, service worker is the best one because with this one you can have your cache more programmatically. And I think you guys have heard about that as well. Putting applications on fire. So your application idealistically needs to be fast, and you can handle that with all the network strategies for performance. And then you can integrate it better with adding to home screen functionality. And then you can have a web application that is reliable using service worker, and you can engage users to come back to your application with push notifications and other stuff that you can add later on. And when you start using HTTPS, there are a lot of web APIs that you can use. For example, for people that are using e-commerce, you can have the payments request API, for example, which is really nice. You can request the phone to pay, and then it's very easy for the user to just spend more money in your stuff. What I want to say, I've been telling a lot of stuff, and the message that I want to pass here is that this is a daily progress. I'm not going to go tomorrow and create an epic with a lot of Jira tickets and improve your application performance X time. But instead, what's ideally is that you inject the performance worry in a daily basis. So in the same way that you have code review or you writing unit tests, you need to worry about performance. And then you need to worry, like, if this code can be written better, if this data structure maybe it's not the best one to handle this functionality that you're trying to build. So it's a daily progress, and you might not get a big improvement in the first one test, but if you start worrying in a daily process about performance, in the long run you'll get a very big win. Just to recap, performance on the web, there is like two big classes, the network and the hardware. When it comes to hardware, there is two big topics that I mentioned here, which is basically remove unnecessary JavaScript, delay the loading of non-critical JavaScript, and use something else instead of JavaScript. For example, Flexbox and Grid and CSS animations. I wrote a blog post in which I basically wrote everything that I just said, and also here it has all the links that I used to build this content, and that's all. Thank you.